Hello, my name is John Sloan. I'm the Executive Vice President for Not So Secure USA. I want to thank you for joining this exciting, extremely informative webinar, Cloud, Stealing the Silver Lining. Before we get into the heart of the presentation, I want to first highlight a little bit about who we are. Not So Secure is an intricate part of our Clarinet cybersecurity practice. Clarinet, our parent company, is one of the largest managed service providers in Europe and abroad, focused on modernizing and running critical applications and infrastructure 24/7 for our customers. The Clarinet cybersecurity practice has over 20 years of experience in cybersecurity services and training for some of the biggest brands across the globe. We are one of the largest training partners of the globally acclaimed Black Hat conferences, where we train hundreds of participants in cybersecurity every year. What differentiates us from our competitors in cybersecurity is we hack and we teach. Our teachers are our hackers, enabling us to provide the most researched and capable penetration testers in the market. As teachers, our hacker training program encompasses training that supports beginners, which are individuals with little to no security experience, all the way up to advanced, to include advanced infrastructure hacking and advanced web hacking. We also have specialized cybersecurity training focused on DevSecOps and hacking and securing cloud. This webinar is an introductory to our two-day Hacking and Securing Cloud Infrastructure training course. At the end of the webinar, we will provide additional information on how and where you can attend our cloud training course. As hackers, we provide white box and gray box penetration testing services for your business applications, infrastructure, cloud, and mobile environments. Additionally, we provide successful black box red team security assessments where we leverage our hacking expertise to find vulnerabilities that vulnerability scans are not able to identify. This wraps up a little bit about who we are. And now, without further ado, I welcome Martin Cernak, who is going to give us a unique hacker insight into hacking and securing cloud infrastructure. There will be a question and answer session at the end of the webinar. Please feel free to submit questions via chat throughout the session. We will gather all questions and present them back during Q&A. Additionally, we do have a special prize draw to attend one of our next live delivery and hacking and securing cloud infrastructure courses, which I'll talk about in a little bit more detail a little bit later on in this session. So Martin.
Thank you very much, John, for that great introduction. So welcome once more from me, whether it's morning, afternoon, or evening for wherever you are in the world. My name is Martin Cernak. I am a senior security consultant here at Not So Secure. I've been working in InfoSec officially for about 6 years, but I've always had deep interest in cybersecurity. But before those years, I was just a software developer. During the 6 years, I've managed to accumulate a bunch of certifications, ranging from NetSec towards cloud through web app security. But more importantly, I really like speaking. I really like delivering training, be it at Black Hat, Checkpoint QA, any other means I've got to deliver trainings. And yeah, I guess most importantly, I'm a massive computer science geek. It's what I've got my master's in. And yeah, it really caught me, and it never let go. But enough about me. Let's take a look at the agenda for today. So first off, we're going to talk a little bit about the cloud and why does it matter, and how do you properly get into cloud. And then we're going to look at some cloud-specific services, discuss the attack surface that's there, take a look at some tooling as well. Also, I've tried to make this as practical as possible, so I've got a bunch of case studies throughout the presentation that I'll be discussing with you guys, and then we'll close it off with time for questions. So let's start. So why are we even here? Why are we talking about cloud? Well, cloud had this moniker of being such a buzzword a couple of years ago, similar with things like big data or machine learning or artificial intelligence or blockchain. But I think cloud is very specific in the way that it prevailed and it sort of survived this hype wave of everybody had to have cloud. And I think that's underlined by, for example, our parent company, Clarinet. They've got a dedicated department for people, for companies that are moving into cloud. So that department is full of people that help that transition. So just the sheer flow of businesses that are still moving into cloud today is immense. And I think also, especially the events of the pandemic, so last year and this year as well, had made it very clear that there's a lot to be gained from outsourcing some of your infrastructure worries, right? So if you are compelled to stay at home, it's a little bit difficult to order a new VPN aggregate so that your entire company can work remotely. Yeah, it's a bit difficult to do when everyone's compelled to stay at home. But with cloud, that was made a lot easier. And I think if you look at some statistics, I think about a week ago, I read an article that said that about 60% of Amazon's profit comes from AWS, just AWS, which is crazy. So yeah, clearly cloud is here to stay. Okay, so how do you get into cloud? Well, there's multiple scenarios. If you are a new company, if you are a startup, cloud is particularly a good choice, right? Because you've got a blank canvas and you can very easily start building things in the cloud. You don't have any sort of backwards compatibility luggage or SLAs to uphold from the past years. So that makes it a lot easier to get started in the cloud. Especially since, again, this was an AWS conference, I think, and one of the points raised in a keynote some time ago was that it's really good because it allows you to fail early. While that sounds bad to fail early, it actually makes perfect sense, right? Because if you are a startup and you need to build up your infrastructure, it's very expensive and it's very time consuming, and you do take on a lot of responsibility if you're building out your own server room. There's racks of hardware and it's very expensive, and you need to maintain it. But if in 6-12 months the startup doesn't pan out, then you're stuck with this closet full of hardware. But if you do utilize the cloud, you don't have that problem, right? You just stop paying a monthly subscription and you're all good. So that's the easier scenario when you starting from scratch. But if you already have infrastructure that you need to move into the cloud, that gets a little bit difficult because there's multiple ways you can go about this. You can essentially do something that's called lift and shift, where you pretty much just pack up what you've had on premise and you move it to the cloud and you just run it in the cloud. But that's not really in the spirit of cloud because at that point, you're not really integrating yourself or your infrastructure with the cloud environment. So you can't really reap the benefits that come from that sort of deeper integration. So there are other ways you can go about this. You can sort of re-architect or refactor your application to maybe break it up into smaller chunks, containerize them, and that way you get really good scale in, scale out opportunities. Or you can even go crazy and just completely disregard or discard your existing software. So your in-house CRM that wasn't working that well anyway, you just get rid of it and instead subscribe to software as a service option like Salesforce. Because at that point, you really don't need to care about the servers, the backups, the power to the servers, and anything like that. So now multiple ways of moving from on-prem to cloud, but the ones that help you reach more benefits are more, there's definitely more effort required for the actual migration. And when you finally do migrate, there can be some security issues that arise just from that migration. So because cloud is such a paradigm shift from your conventional on-prem infrastructure, there are some assumptions that no longer really apply. I'd say the biggest one being that everything in the cloud is presented as public. Of course, you can have little segments of your cloud environment on private circuits and have it sort of shielded, but it's definitely not to the same extent as your on-prem infrastructure was ever meant to be. But setting that aside, from the years of from the years of our work, I'd say that the biggest issues stem from just misconfigurations, and it's going to be a theme that's going to carry throughout this this webinar. It is to some extent easy to misconfigure things, even with the best of intentions, and there are some security implications that arise from that. And most of those misconfigurations revolve around access control management. So it's common that you'll see, for example, an API that was meant to be internal, but it was migrated to the cloud. The security assumptions around it no longer applied, and it was a couple of those endpoints that were never meant to be online ended up online. So that can lead to pretty serious issues depending on what you've got on the API. There's also some issues with credential leakage. We'll see a couple examples of that later on as well. But the last point I'd like to point out on this slide is the very last bullet point, and that's data sovereignty. So because we're running in the US time zone, I'm assuming a lot of US companies don't have to worry about GDPR that much as we do in Europe. But it's something to think about, because if you do move your data to a location that has stricter rules and data protection laws, again, it might cause you a headache. So it's something that you might have to think about. And again, it's a change from on-premise, where you probably have your own data center somewhere nearby your office, or at least in the same country, presumably. Right, so this is called a responsibility matrix, and it kind of follows on the idea that I introduced on the previous slide. So on the left-hand side column, the most left-hand side column says on-premise. Essentially, that's your situation when you are dealing with things on-premise. When you've got your own data center, you need to manage pretty much everything yourself, which gives you extreme amounts of control, but also it lays a lot of responsibility on you. So you do need to care about anything from actual physical security throughout service and maintenance. What if the power grid goes down, or what if the ISP that we're using has a blackout? Do we have another backup provider, or how do we deal with all of these things? But as soon as you start moving right on this slide, even just infrastructure as a service, even just the second leftmost column, you immediately get all of that responsibilities immediately lifted from you, right? You don't have to worry about UPS and UPS as in uninterruptible power supply, not in SD company, or backup internet lines and anything like that. You only care about the things that you build on that infrastructure. And again, as you move further right through containers, platform as a service, or even function as a service, again, lots and lots of things are lifted away from you, and they become somebody else's problem and possibly somebody else's headache, which is always very intriguing. But essentially, the three things I've outlined on this slide are the things that you have to care about regardless of how much you outsource. And that being most importantly, the data that you've got in the cloud, and the access management. So managing the access that people will have to that data. That is something that nobody can really help you with, and that's something you need to manage yourself. And unfortunately, that tends to be the most problematic area, as we'll see. So there are some tools to help you with this, to help prevent lots of issues. So pretty much all the cloud vendors provide you with a set of tools. Those tools are very tightly coupled to their respective environments, which is good and also kind of bad. It's good because a lot of the internals are abstracted away from you, so you only get a couple of levers, a couple of buttons to push, and that's how you control everything. The negative side of it is because a lot of it is kind of set in stone. You can't. It's not as flexible, right? So you are given a product, and if you don't like what it does, you can't really modify it much. So there's definitely still space for third-party tools, especially if you are in a multi-cloud or hybrid environment, which is more common than you would think, especially if one company acquires another. They've both got a cloud subscription, but it's to different vendors. So suddenly you've got this massive duplication of effort, and you need to manage it somehow. So that's a good place for a third-party tool that is not limited to just one cloud environment. So this is a small screenshot from a really large table that I've taken from the website that's referenced on the bottom of the slide there. And essentially what they do is they map your on-premise terminology or active network elements, so just things you would deal with on-premise in your own data center. And they take a list of those and they map it to offerings by various cloud providers. So you can see that essentially every grayed out cell is something that is not or only partially covered by the offerings by that specific provider. So you can see, so this is just a small snippet. If you visit that website, the list is much longer, and I couldn't possibly fit it on one slide. So yeah, but the point is, you can see that there's definitely still a market for third-party tools. All right, so say you've done all of that, but you are being attacked in the cloud. So how does that attack work? So essentially, it works very similar to an attack on your own infrastructure. There's not a big change there. The actual change is within those separate steps. So each and every attack is going to have essentially those 4 phases, where the attackers first enumerate things about you, about the website that you're running, about the subscriptions that you might have, about any subdomains that you may be hosting. They try to identify a weak link and gain entry into your environment through that weak link. And after they've done that, they're going to exploit and they're going to run some exploits. They're going to essentially exploit your environment, try to establish themselves, move laterally, and finally essentially maintain some persistence by backdooring your environment. And that cycle is going to continue until that attacker effectively reaches their goal. So breaking this down into discrete steps, first looking at the enumeration step, how does that look in the cloud? Well, it might be slightly different to your classic on-prem scenario, because in the cloud, there's a lot of unification that happened, and a lot of information can be queried from a single place. So breaking down enumeration in the cloud into 2 sections, first talking about asset enumeration, or you might have heard this referred to as external asset mapping. Essentially, everything on the internet has a domain assigned with a domain name. So you start with that, you look through subdomains, you look for subscriptions that that company might have. For example, are they using Office 365, or are they using any other service that we might try to exploit our way through to our target? Or you rely on OSINT, which stands for Open Source Intelligence, typically sort of passive information sources such as search engines, certificate transparency logs, maybe social networks, pretty much anything you can think of just gathering information about someone. And after you've done that, after you've enumerated lots of assets, then you pivot towards credential hunting. So that's the second step of enumeration. You're essentially trying to look for usernames, again, through various means, and this gets easy in the cloud, especially within Azure. If your corporation has subscription to Azure AD, you are outright vulnerable to username enumeration because of how Azure works. But even if not, you can deploy other techniques. For example, looking through possible public code repositories, Google Docking, again, social networking, phishing, things like that. So speaking of enumeration, probably one of the easiest way to go about it and perform some active enumeration is through DNS. So DNS is inherently public, which is great because anyone on the internet can query information about any server and get some form of response. But it also means that anyone querying information about you is going to get lots of answers. So this is just a sample DNS query. We're looking at the results here. Again, most of this is not really interesting, and it's mostly data for just making the internet work. But if you look at the bottom of the slide, the last couple lines are interesting. So the TXT records there, for example, include things like an SPF record that says anything from Outlook.com can send emails as this target company. So now we've got some image in our heads. Okay, these people are using O365 most likely. They also seem to have some integration with Google because they've got the Google site verification tag in there, and Facebook as well. So just running a simple DNS query can actually paint you a good picture. It's a good starting point. But the thing about most of these attacks is enumeration. It's automation, right? So you don't want to be doing this by hand, and there are many tools that you can use to do this for you, right? So we're looking at a tool called DNS Scan that essentially does the same thing, but it formats it a little more nicely. And we can see pretty much all the information that we've seen before, but it also does a lot more enumeration, a lot more active, more sort of brute forcey enumeration, which you might or might not want to run depending on how stealthy you want to be as an attacker. Another source of information that is really, really nice, just because its purpose is to make the internet a safer place, but the byproduct is that each and every TLS or SSL certificate issued ever has to be recorded in these giant logs, and those logs are searchable. So actually, I believe since June this year, it's pretty much mandatory to, in order for your website to work, your certificate that was issued to you has to be contained within those logs. So it's also a good place to learn about someone, right? So what you can do is just search for a domain within those logs, and you'll get lots and lots of results, as you can see on the bottommost screenshot there. Looking for a target of victim.cloud, we're also getting information about possible subdomain AWS lambda.victim.cloud. That's at the bottom and middle of the slide. So you get lots of interesting information just out of various passive sources of information like this. So this is a very specific, very cloud-specific scenario. So looking at storage accounts. So I would say if I ask people, okay, what sort of AWS service would you say is the most known one or the most common one? Well, people either say EC2, which means running VMs, or they say S3, which means storage. So S3, as in an AWS storage solution, and not just S3, not just AWS, but GCP, Azure as well. It's a super deeply integrated storage solution for use within the cloud. Right, so it's not just a place for you to put in data, like to upload images, assets for your website and host them online. It's much more than that, right? So it tends to act as a primary storage for either function as a service, platform as a service, or other ecosystems within a cloud environment. And the interesting thing is that all that data has to be contained within a storage container. And that storage container is sometimes referred to as a bucket. Especially AWS and GCP refer to their containers as buckets. And those buckets have to have names. And those names have to be globally unique, at least within the provider's universe. Right? So you can't have two Amazon S3 buckets with the same name. But that also makes it really easy for attackers to enumerate existing buckets, because if you try to create a bucket with that name and it's not possible, then you know that bucket already exists somewhere. And you can target that bucket and look through, okay, do I have access to it? Can I list things from it? Can I write things to it? And that brings us to the next point, where we start the chain of misconfigurations. I'd say that the most widespread issue with storage accounts is just bad access control. Bad access control management, you overlooking something, and that's something that you've overlooked being later exploited by attackers. Because I'm sure I don't need to mention that making your confidential data public can lead to not a good scenario. So sticking with S3 for this slide, this is a statistic that was done, and it found that all the S3 buckets that there are, about 10% of them are public, and that in itself is completely fine. That's not a problem. But looking at that 10% volume of buckets and checking whether the public can not just read them but also write to them, they found that about 20% buckets were actually writable by the public. And that gets scary really quickly, right? Because if you are managing an environment that's got S3 buckets in it, and some of them are public, and some of those public buckets are also writable by anyone on the internet, that people on the internet are going to try write things to that bucket, and it might not always be the best things there are. It might not always be good things. It might be something illegal. It might be something that you will be then held accountable for because it is your bucket. It is your storage, and someone put it there. Well, that's okay, but you are hosting it, and that's the problem. So those percentages, okay, those percentages are very relative, and they might not mean much to you, but there are companies that make it essentially their business to enumerate said buckets within AWS, Azure, or GCP, and essentially just look through all those storage containers, look at all the files, and make an index, and essentially provide you with something like Google, but it only targets S3 buckets, Azure blobs, GCP buckets. So what we can see here is that there's about 500,000 buckets that are essentially accessible by this search engine of sorts, and the contents are being indexed, right? So it indexed about 2 billion files, and you can search through those files. So I think very fitting. It's a very fitting that this tool is made available by an organization called Grey Hat Warfare, because it definitely seems like a gray area. I mean, after all, those buckets are public, but some of them might not be. And if you think about what kind of person needs this search engine to search through public files on storage platforms, I'm not sure there are that many legitimate cases. But of course, attackers can leverage lots of tools that are publicly accessible, publicly available to them. So it's not just utilizing one search engine. They can run much more targeted attacks. As we can see on the screenshot, so it's just running some targeted attack against all the big three providers. It's doing some Azure checks, looking for S3 buckets, and even looking for GCP buckets. And with that, we come to one of the first case studies that I've got for you. So this is a case study of a utility called Firmware Update, which if you use Linux, you might be familiar with. Essentially, it's a framework that a lot of manufacturers agreed to, and it means that if you've got a laptop, for example, you can upgrade firmware for various components on that laptop without the need of installing Windows, because that used to be the case. It used to be the case that you'd have to have Windows installed and everything would only work on Windows, but that has luckily changed quite a lot. So, for example, with this software, you can update firmware of various components of your laptop from Linux as well. Unfortunately, the authors were relying on an S3 bucket, or just using S3 buckets for running and maintaining this solution, which again in itself is completely fine and completely valid. The problem was that at some point they've stopped using those S3 buckets and they didn't want to pay for them any longer, so they just deregistered them. They've removed them and they were no longer in control of those buckets. But that code that was checking certain buckets stayed in the code base, and somebody noticed that, and they've noticed that it's querying a bucket that doesn't exist. So what they've done is they just sign up for a bucket of this name because it was no longer registered. And if you were using FWUPD at the time, in your update manager, you might have spotted something a bit weird, which, as you can see from the screenshot, is definitely not something you want to see on your laptop. So that's a problem with the cloud, forgetting links to external places. Similar scenario with Azure Storage. So within Azure Storage, there is a mechanism called SAS. It's essentially a token. So SAS means shared access signature. And it essentially takes form of a token. And if you tell that token to someone, they can use it to access files from your storage that just the general public might not have access to. Again, that's a completely valid thing to use. However, what sometimes happens is people don't realize how powerful these SAS URLs can be, and they might over-provision them. So as attackers, what we can do is just hunt for those strings, hunt for the well-known, well-defined token structure of the SAS URL, and then later plug it into some tools that can help us enumerate and identify assets available behind that shared access signature. And sometimes that token can even provide you with write access. So you can try and plant a backdoor, for example, try and override some storage for Azure functions and write your own code there and just wait for that function to be invoked at a later point and your code to run. And there's a lot of attack surface there. We've written an article about this, so that's the reference at the bottom of the slide there. Yeah, again, we've only got an hour, so I don't have that much time to go into it. But something that I'd like to go a little deeper into is the Elastic Beanstalk case study. So Elastic Beanstalk is an offering from AWS. Essentially, it's a platform as a service offering. So if you are a developer, you have coded this application in say PHP, and you want to host it somewhere, you can very easily just fire up AWS console, go to the Beanstalk control panel and just create an environment, say you want PHP, and just deploy, and you're done. Right? It sets up everything for you. But because it's automated, it has some downsides to it. So we were looking at this case of an Elastic Beanstalk deployment, and we've managed to find an SSRF vulnerability. So that's a server-side request forgery vulnerability. And we were able to leverage that vulnerability to read something from the metadata API. So metadata API is a very core concept in pretty much all the cloud providers. And it's a service that you can talk to internally, and it contains a lot of sensitive information. So what we were able to get out of there was some just information about who was running that instance, where it was being run, but also a set of AWS credentials. So we've managed to extract those credentials and set them up for our use. And while we were enumerating what kind of access we've gained, we've noticed that there wasn't much we could do. We couldn't list S3 buckets, but it turns out that the way Beanstalk names things is predictable. And based on the information that we've already gathered, we could have taken an educated guess and essentially reconstruct some of the names that Beanstalk used to create buckets. So even though we couldn't list all of them, if we knew one existed, we could list that one bucket. So we couldn't get a list, but we could access them individually if we knew the names, which we've managed to reconstruct using the documentation. And essentially, we were quite lucky because the application that we were testing or looking at, it had like a nightly build system, essentially something that is fairly common in the software development industry. You've got a pipeline set up that, for example, say nightly takes all the source code, builds it, and checks that it's still working. And you've always got like a recent build of your application that way. And it was the same case for this application. However, that also allowed us to run the code that we've planted in that bucket. So that's something I'd like to quickly demo here. I've got a pre-recorded demo just because doing demos live is a recipe for disaster at all times. If you've ever presented a demo, you'll know what I'm talking about. So here we can see us accessing this application. It's essentially loading a document from somewhere, and we're able to influence where it's loading the document from. So we'll first try to read some information internally. So we're just trying to read the Apache server status, which seemed to have worked. So we've got that's a good starting point. But we're more interested in the metadata API service. So again, that's something that you can only access internally from AWS, but it seems to be working in this case. So we're going to query it for some confidential information, right? We're going to try to export some AWS credentials from it. So there are some credentials there. So let's try and read them. Right. So this is what you want to see as a pen tester. So we've managed to export some credentials that the Elastic Beanstalk deployment was using to talk to AWS, but we've managed to exfiltrate that information to us. So now we can impersonate the Beanstalk deployment and hopefully do things within AWS. So what we're going to do here is we're going to set up our environment so that essentially to AWS, we look like that Beanstalk deployment. So we're just going to set up our environment variables to reflect the access key we've discovered, the session token, and the secret access key. And as you can see, this app is deployed in US East 1. So we're also going to set up the default region to make our life a little bit easier. And we're going to check if those credentials worked. and they indeed worked. Excellent. So again, more information. We now know the account number of the owner. So we can try and list buckets here, and it doesn't work. So it just tells us access denied. You can't list buckets. But if you take a look at the documentation here, you will notice that the permissions that are assigned to a Beanstalk deployment that we are now in control of, while they don't allow you to list buckets, they allow you to read buckets if you know the name and if it starts with Elastic Beanstalk, which all the buckets created by Elastic Beanstalk do. So you simply just take the region, you utilize the account number, and even though we were not able to list all buckets, we can list specific buckets, as we've seen here. So that's excellent for us. Now let's try to copy everything out of that bucket to our local machine. Excellent. So now we can try to plant a backdoor. So I'm just gonna plant a PHP backdoor because that's the language of the application. Put it back into the archive and upload it back to that bucket we've discovered. And yeah, switching back to the console, essentially waiting for that CI/CD pipeline to kick in. We've now got a web shell on this Elastic Beanstalk deployment, which is, I'm pretty certain, not what the owner intended. Okay, so that demo essentially showed us over provisioning of certain roles. In this case, it wasn't even the user's fault; they were just following documentation, right? I mean, they stayed within the bounds of the documentation. But it does outline the problem with access control management and over provisioning things within the cloud, which again are one of the top problems in the cloud. And I think that ties in very nicely to this slide here, where we discuss shadow admins. So very similar to what we've just seen, where we've gained access to some environment and we couldn't do an action directly, but we could do the action indirectly through other means, right? We've read the documentation, we've discovered that we can guess the names with pretty good precision, for example. And it's a very similar thing with shadow admins within the cloud environments, because essentially a shadow admin is a user that isn't an admin, but they have the privileges to make themselves effectively an administrator. Right, so same scenario, they can't directly be an administrator, but they have the means of making themselves an admin. Right, so there's multiple steps involved, but it leads to the same goal. And those kind of problems tend to be overlooked from time to time, because if you don't have the knowledge about all the roles within an environment, you might overlook someone who isn't an admin, but effectively they are. And sometimes that even happens to AWS, right? Because we're all people and we all make mistakes. So this case study is about an offering by AWS called the Elastic Transcoder. So AWS has many offerings, many services that they offer. And in order to help you manage access to those services for all of the users of your organization, they give you AWS policies. So it's essentially a packet, a parcel, a package of permissions that you can assign to someone. And there was this one policy called Amazon Elastic Transcoder Full Access. I mean, it worked. It did allow people to just use the Elastic Transcoder service, which is perfect. But also it contained a dangerous permission. It was the put role policy permission, which essentially would allow that grantee to attach an inline policy to some role and in effect escalate their own privilege. So AWS were told about this, and they fixed it fairly promptly. But it just goes to show that even AWS make mistakes from time to time, and anyone with this policy assigned to them could have effectively been a shadow admin should they have chosen to go malicious. And with that, moving on to other means of over-provisioning things. So this service is called AWS Cognito. It's another case study that I'm going to demo. And essentially, Cognito is a really cool service. It essentially allows you to outsource user management and just all the like logging functionality, forgotten passwords, signups, all of that can be outsourced to this service, right? So you don't have to reinvent the wheel if you are coding up a mobile app or a web app. So a lot of research has been done into this. 2 years ago, there was a pretty good talk at Black Hat by Andres Verianjo. I've probably butchered his name. I hope he's not in the audience here today. And we've since expanded on that research as well. But I'm going to run a quick demo, just demoing Cognito to you, and how over provisioning roles within Cognito can lead to pretty bad consequences. So I had to cut this down quite a lot. This would have been like a 20-minute demo, so I had to cut it down quite a lot. So essentially what we're doing here is we're just looking at a website, and what you can see here is just got a login form and nothing else, right? It's just a login form. There isn't even a way to create an account, nothing like that. So we're looking at it from sort of a adversary's point of view. We're going to check the HTML source code of it as well. And what we can see here are just some JavaScript libraries. Again, normally we would go through these, but in the interest of time, I'm skipping right to the configuration file here. And that configuration file seems to contain some information relating to the Cognito service. So there seem to be a couple of constants here that are used by Cognito just to function. So those are not necessarily sensitive or secretive. Those are fairly public, because that website that loads in your browser needs to tell your browser like all these constants so it can actually interact with the service properly. So there's nothing confidential about these, but what you can do with them is you can just go around the website and just talk to the AWS Cognito service directly with the use of these constants, right? So we can identify as this web app and try to talk to Cognito directly from our terminal, not just through the website, but through our terminal. So that's what we're going to do. We're going to try to create an account within Cognito just by use of some of these constants. So it seems to have worked. It sent us an email. So we need to go to our email account, find the confirmation code, and essentially finalize the sign-up procedure, again, through the terminal, completely ignoring the website. So now that we've created an account, supposedly on this website, we can try and sign in, and it happily signs us in, but it's not very happy about us logging in. It just says, you don't have access to this application, you're not supposed to be here. And that's fair enough. So what we can do is just take a look at, after we've logged in, some of the information has been passed on to us. Essentially, a JWT token describing our access has been provided from Cognito to us, and that's how we authenticate. So here we can just see some information, some more information about Cognito, and we can extract that information and use it to, again, talk to Cognito directly. Right, so here we're saying, dear Cognito, I am authenticated. Please give me access. Essentially, Cognito is there to issue people with very temporary access to AWS. It's a bit of a weird service, but that's what it does in a nutshell. It logs you in, and after you've logged in, it allows you to gain temporary access to S3 buckets or EC2 instances or anything like that. And again, the website wouldn't allow us to do any of that, but because Cognito is accessible not just from a third-party website, but also through the terminal, through the use of official tooling from Amazon, we can do that. So we can essentially request a set of credentials from Cognito using the login credentials that we've just created. Okay, so that's what we've done, and Cognito has very graciously provided us with a temporary set of credentials. So once again, we're going to set up those credentials in a terminal, essentially logging in as that role that Cognito provided for us. Set up the region as well. Normally this is the point where we would be running enumeration scripts and trying to see what kind of access we've gained or have been granted. But again, for the interest of time, I'm just picking one service that we've had access to in this specific instance, and that was the secrets manager. So the secrets manager typically holds, well, secrets, things like passwords, API keys, private keys, certificates, everything like that. All of that information tends to be stored in the secrets manager. So essentially, yeah, we're just completely bypassing the website and just talking to Cognito directly. We've managed to export some sensitive information out of AWS by gaining access to AWS, and that's all by design. But this is an example of an over-provisioned role within Cognito that can lead to these consequences. Okay, yeah, so over-provisioning things definitely bad. So if you over provision roles and permissions, people might get access to your AWS environment, or well, any environment, any cloud environment. And this can lead to a pretty bad situation where somebody might essentially start using your subscription, and they're just using it for themselves, for their own purposes, but you are paying the bill, right? Because they're logged in as you, and you never want to be in that situation. But it's very easy to get in that situation, as we've just seen on the demo. So that was an example of a misconfigured permissions or just over-provisioned roles for that specific service. But what can also happen is you can accidentally leak credentials out, and it happens more than you would think. There was this piece of software called ShishKit, which essentially you could point it in a direction of some code repositories, and it would scan those repositories for lots of secrets, because a lot of secrets like access key IDs, secret access keys, tokens, and things like that, they have a very specific format, so that they tend to stand out. And that's what this tool leveraged, essentially. So it would just scan the repository looking for interesting things in it, and it would present with the results. Again, similar thing can be done manually. So, for example, this is on GitHub. We're searching for a keyword that tends to be associated with, or it tends to be in proximity within your source code to some credentials if you've hard-coded them. Okay, so that's a couple of examples how you can accidentally leak your credentials or over-provision permissions, and somebody can get in, right? So once they get in, what can they do? So here's a case study of Codespaces. So Codespaces used to be a source code hosting provider, and essentially somebody got in and they've started removing things. And that's really bad, because once you remove something, AWS or GCP or Azure, they are contractually obliged to safely destroy that data, right? So an attacker logged in, removed everything, and then they went away. And Codespaces effectively had to shut doors overnight because they've lost everything, right? They've lost the website, all of their intellectual property, all the code, all the user data, everything was deleted, even the backups. And there was just no way to restore from that. So that is an extreme scenario, but it can happen. Again, similar thing happened to Tesla, but this time the attackers essentially were just mining cryptocurrencies, which is, again, not very good, but it happens fairly frequently. It's a good way of monetizing your access to free hardware. And it brings me to sort of making a comment about how the cloud environment tends to be uniform, which is really good, and it's also really bad. So it really, yeah, those really are the two sides of the same coin, right? Because when you think about it from the defense perspective, you have really good tools of keeping track of your environment, right? There's not going to be that one server that's been there for years because someone set it up and you don't know what it does, and everybody is too scared to turn it off because it might break something, right? Because in the cloud, you pay for what you use, so each of your servers is going to be a line on an invoice, so it's very easy to keep track of the environment, and there are many tools built in that can help you with that. Also just auditing everything, right? So because it's a monolithic environment, and it's so integrated, it's really easy to have an audit trail of which user did what and when did it happen. So you can always point the finger or talk to the right person. You always know what happened and who did it. And at least for me personally, most importantly, automation of things is absolutely key. Essentially, making use of cloud APIs that can just query information for you, put it in a report, tell you if something changed, and you can just have that report on your desk like every day, every week, every month, whenever you are making these rounds and checking everything. but also all of the good things that I just said can be used against you, right? Because the attackers also have access to a wide range of automated reconnaissance tools, right? So if there is a good reconnaissance tool against AWS, and you deploy something into AWS, you are automatically kind of susceptible to that tool, to enumeration done by that tool. It also brings forward standardized attack paths, and it streamlines that step of the attack, right? Because at that point, an attacker, so if you've ever had a red team engagement done, I can guarantee you that the majority of that engagement, the pen testers behind it, were planning the best attack path that will generate the least noise and will have the biggest chances of success. And that's because each environment is different, but within the cloud, well, the services don't change. So it streamlines that part of the attack, and it makes attacking easier. And most importantly, something we didn't really have that much time to talk about, the metadata API and things like that, naming patterns, everything is very publicly documented, right? So it's like you are losing that layer of obscurity that you have around your environment because you're the only people who know it. Now the attackers know it too, because everything is publicly documented, everything is standardized, everything is the same. So that can lead to trouble. But I'd like to leave you with a couple of leave on a positive note. So coming back to the defense side of things, this is a really cool tool. Again, all the cloud providers have variants of this tool as well. But essentially, it's a tool that helps you to gather all the facts about your environment, and you can run checks on it. So you can, for example, if you're running AWS using S3, if you by accident have a bucket which is publicly accessible and someone accidentally misconfigures something and makes it publicly writable too, obviously you don't want that. So you can have this rule always checking, and should it discover a discrepancy, it will tell you, it will email, or it will somehow make it known, or it can even automatically remediate and fix it for you automatically, which I think is really excellent. And I think that's where cloud really shines. Because of this deep cross integration, you can you can automatically fix things, which I think is just really good. But yeah, I think that's pretty much everything from my side. I've tried to cram lots of interesting information into this webinar, so hopefully that was interesting for you to listen to. So I'm now going to hand over back to John, and he's going to talk a little bit about some upcoming training dates and future interesting things that we've got planned. So John, over to you.
Thank you, Martin. Before we get into Q&A, as previously mentioned, this webinar is a precursor to our Hacking and Securing Cloud Infrastructure training course. If you have a need to gain greater knowledge regarding pen testing, red teaming, and overall how to better manage and resolve vulnerabilities in your IT environment, then this course on Hacking and Securing Cloud Infrastructure is a critical first step towards you reaching your objectives. The next few slides provides a list of our upcoming remote training courses and informative webinars. These that are on here now are some upcoming Hacking and Securing Cloud Infrastructure courses with dates. I do want to point out the discount code of 20%, so please be sure to capture that. All right, next slide. Next slide is some additional upcoming webinars. I also want to point out that using the email that you provided, we will be providing this information as well. So you have that information that you can use to track these upcoming courses as well as these webinars. All right, and then the next slide, as we spoke about in the beginning, is a special bonus for attending this webinar. Just by speaking to one of our team members about your training or pen testing requirements, you can become eligible to win a free place on our next live remote delivery cloud training course. To arrange your call and gain entry to the prize draw, please email us at contact@notsosecure.com. All right, and as a reminder, we teach and we hack. If you are in the need for or have future needs for cybersecurity risk assessments, we'd be super grateful for the opportunity to perform a risk assessment on your behalf. We look forward to speaking with you in the near future. So thank you. We now open it up for questions and answers. Please use chat to ask your questions, and I'm going to hand it over to Lizzie to help coordinate that. Lizzie?
Yeah, thank you there, John. Yeah, thank you, Martin, there as well. It was a really interesting presentation there. I really enjoyed it myself. Yeah, please feel free to ask any questions now. We have had a few already in, which is great. So I'll just get asking with them. So Martin, the first question we've had in is, how do you keep up to date with cloud attacks, or where can you find any news about cloud vulnerabilities?
Thank you, Lizzie. So yeah, that's a great question. So obviously, cloud being so dynamic, it's a bit difficult to keep on top of everything. And yes, just cybersecurity as a field moving forward so quickly. Everybody wants that little piece of fame, so it's sometimes difficult to distinguish between really important information and something just being maybe less important but having better marketing. So I would say if you are really into cybersecurity, you definitely should be on Twitter, because Twitter is the place where a lot of security researchers congregate. And for example, if you look up my boss, who's called Anand, so if you just Google "not so secure Anand," you'll probably spot him right away. He's got quite the following, and he's following a really good curated list of sources. So I think he's a great inspiration of sources to follow. But yeah, I would probably point out, especially social media, Reddit, the subreddit NetSec also goes into detail about cloud security, so that's a good one too. Some discussion takes place on Discord and more private forums. So yeah, it really depends on how deep you want to go. I'd say for cursory understanding, just following some interesting feeds on Twitter can definitely help. And if you are more into more technical side of things, just get in touch with me after the webinar, and I can point you in the right direction.
Great, thank you there, Martin. Another question we've had in is, for the people coming from network security experience and want to go towards application and cloud security, what would be the knowledge they need to bridge the gap between the two?
Well, again, that's a really good question. So if you've already got NetSec experience, I feel like cloud security shouldn't come as a big shock to you. Again, in the I can't pull up the slides of the training right now, but we do go into some details of sort of mapping out a lot of the cloud specific things onto concepts that you've already know. But cloud is kind of it's I feel like it's half AppSec, half NetSec. So if you don't have any application security experience, it might be good to learn a programming language just so you can understand AppSec a little bit better. If you already know a programming language, I'd suggest trying to build something like a website, because websites are very easy to make insecurely. And at least that's the way I've learned most things that I know, just from doing things on my own and understanding the mistakes I inevitably made and later fixing them.
Great, thank you so much. And another question we've had in is, obviously this webinar is related to hacking and securing cloud infrastructure, but do you know, Martin, what the high level topics of infrastructure hacking are? Just for one of our attendees.
So I'm not 100% sure, unfortunately, but I would expect something that starts at an external perspective. So you probably learn about things like network scanning, port scanning, all the techniques that you can use, and looking up services and how they function, and what are good sources of information for a specific service, looking for known exploits. Again, I feel like I'm really not doing it justice because I'm not on that team, unfortunately.
No, that's great. Anyway, thank you for that, Martin. I just thought I'd ask a question anyway, but we will get back to the attendee who has asked this question with further details on that question. So yeah, thank you so much for explaining that, Martin, there as best as you can. One more question we've had in too is, you mentioned financial attacks. So how bad can it get in terms of monetary loss and how to defend against it?
Yeah, so the financial attacks can be quite scary, because when you look at just the brand names of companies that were damaged by those attacks, it's companies like Tesla, Microsoft, even like lots of companies. So the way to combat this is to set budgets. So each cloud environment has a budget policy that you can leverage. So you can, for example, get notified if you've been using the environment for a couple of months and your budget, you always spend like $300-400 a month. It's a very small environment. And then suddenly, the month after, within a week, you burn through that couple $100 budget, you'll immediately get notified, or you can set up other actions to take place. So essentially, you just need to customize it. You just need to make sure it fits your needs, and maybe have some margin for that. But again, there are functionalities for that. But essentially, what you need to do is figure out how much do you spend monthly, and have a budget and lots of alarms set up, so that you will not be surprised when the bill comes. And as in actual numbers, I can give you some numbers from AWS. So if you spin up quite large instances like X1E, 30 times too large, I'd say it comes to about $20,000 a month for one instance. You can spin up many of them within one region, and there are 20 regions. So you're looking at hundreds of thousands of dollars possibly, but that would be a really malicious scenario, but it is possible.
Great. Well, that is all the questions that we've had for today. So I want to thank you again, Martin, for that Q&A session and the presentation as well. And thank you, John, for introducing and closing the webinar there. So I just wanted to say, yes, thank you, John. Yeah, so thank you so much for everyone who's joined today. I hope you found the webinar really interesting and useful. Definitely please take up on our offer of that prize draw. We've got a survey at the end where we can we ask you whether you want to find out more information about that too. And yeah, I hope you enjoy the rest of your day, and really hope you've enjoyed this new webinar that we've had on cloud. So just want to say thank you again to Martin and John and everyone who's joined today. So thank you.
Yep, thank you.
Thank you for having me.
Great day.
Bye. Thank you, everyone. Goodbye.